Thank you, Corey. So I'm very happy to be here. Being from Iowa, you know, we used to say that we're farmers coming to the big city. Now we say we're wind engineers coming to the big city. So we have a lot of wind growing in the heart of corn country now in Iowa and Minnesota and Midwest in general. I have two communications for you today. The first is sort of to try to lay out before you what is the energy system. Can we sort of put a definition, a conceptual way to think about how to look at what we all say the energy system. And the other thing is to consider the projection into the future of what we should do. We do have a lot of the answers today in terms of how to proceed, but there is a missing piece. That is the analytical studies for comparing options really have not matured yet, and they need to. Policy needs to look carefully at the analytical computational analysis of looking into the future with respect to investment into energy infrastructure. So those are the two messages. This is a picture, apologies, it's a little bit hard for you to see, but that tries to lay out this concept of energy system. And we all have in our minds, transmission lines, and certainly that's a major part of it. The electric network that you see on the right-hand side, and then above that, the natural gas network is a critical way that we move energy. And then at the top, the liquid fuel network is another important way to move petroleum. So these are forms of energy. And on the left-hand side, you see the resources that come from fossil energy resources together with renewables. So that's where they come from, and we move them. And then the bottom picture of the U.S., there is an effort to portray our transportation infrastructure that is comprised of our vehicular means, automobile and trucks, also rail, and to some extent ship and barge, particularly up and down the Mississippi is a big player. And then, of course, the airline industry is a big way to move passengers. So the liquid fuel network is, and the natural gas network and the electric are ways to move the energy. And then on the bottom side, we use it not only electrically, but we also use it in transportation to move our motor vehicles and to move our airplanes as we travel around the country. And the right-hand bottom is sort of an interesting piece of the puzzle, and that is rail. It's kind of, rail has been around for many years, but you need to think about the fact that it not only moves commodities and potentially passengers, to some extent passengers today, but potentially a lot more passengers, but it also is like the liquid, natural gas, and electric, is a mover of energy because it is the primary way that we move coal around the country today. So that's kind of plays an interesting piece in terms of both a transportation and an energy movement part of the puzzle. So this is what I put before you as our energy system: electric and the fuels that supply it, and transportation. So in thinking about those two parts, we need to recognize that our overall energy consumption is about 70% in those two areas, electric and transportation. There's another 30% primarily heating, industrial processes, and so forth. Likewise, our overall emissions, carbon dioxide emissions, is about 70% or more from those two sectors, with the rest coming from, again, heating and industrial processes, a few other things. So the point of this slide here is very simple. If you green the electric system and remove that large CO2 emission part, and then electrify the transportation system, you have a very good start at the solution to our global warming problems. Okay? And this is a very scary picture. Please forgive me. And you can't see the numbers there very well. But this is a very important picture. If you want to understand the national energy system from a national perspective, go do a search on, and find this picture and study it for a while and look carefully at the numbers. Let me walk you through just a few of the pieces and then kind of give you homework to do the rest this weekend. The left-hand side are the energy resources that we have. The top being renewables, the bottom being fossils. The right-hand side, residential, commercial, industrial, and transportation are the way we use them. And then at the very far right-hand side, we have used energy and unused energy, with the unused energy being waste or losses. And if you can see the numbers, the unused energy is 57 quads, and you can think of that as percentage. By coincidence, the total number of quads, which is unit of energy in the country on an annual basis, is 100. in 2008. So a very convenient number. So these numbers you can think of in terms of not only quads but percentages. So 57% of our energy is wasted. 43% is utilized in some useful fashion. And the connections between the resources and the right-hand side through these bars, the width of those bars is proportional to the amount of energy that's used, okay? So just run your eyes along just to the right of the resources on the left-hand side. You know, petroleum there at the bottom is a big one, right, with 37%. And then the next largest would be natural gas at 23%, and then just below that is coal, 22%, and then at the top, nuclear. These are the big players, right? Coal, petroleum, natural gas, and nuclear. The rest are minor players today. Okay, so that's the way. And then I just focus on the electric generation side. The energy that goes into the electric generation side is about 40 quads, or 40% of all of our energy use goes through some electric generator somewhere in the country. And then the transportation side, that use is about 27% or 27 quads. There's the 99 quad figure. And then the emphasis on the right-hand side of the split, again, very important to recognize, 57% is waste energy. Okay? And this line is an important line, too, to communicate to you the following fact. Are there any thick connections between the bottom and the top part of this picture? There are small little connections. The point is the transportation and the electric side are just about entirely independent today in terms of energy interdependency between the two. And you recognize this on a day-to-day basis. You use petrol, gasoline in your vehicles, and that has almost nothing to do with the electric generation. You use coal, natural gas, and nuclear to get electric generation. That has nothing to do with your vehicles. Okay, so we know that's changing. Right? This is a picture that kind of makes the point. Electric vehicle fueling station with plug-ins, pluggable hybrid electric vehicles. Obama administration has put in a few $1 billion into the potential of electrifying some rail corridors in the country in the next few years. Technology is moving on the rail side to electrify that. It's there today. We can do it. There's a lot of things to be solved. Warren Buffett, Mid-American Energy, is an electric company in Iowa, actually, one of the largest in the country. He's the owner. He's just bought Build Your Dreams, is a pluggable hybrid electric vehicle manufacturer from China. And so here we have an electric utility owner combining pluggable hybrid technology, and so he knows where the future is going. So here's the same picture. Let me see if I can give you one solution, just one, with respect to the future. Where are we going? So there's a lot of possibilities, and maybe my biggest point here to talk to you about is that the spectrum is huge. And I just want to put one before you, and I'm not even going to claim it's a very good one. I just want to sort of let you see the features and attributes and characteristics of a future solution in terms of our energy issues. Okay, so I'm going to reduce coal from 21 quads, or you can kind of think percent, to 12 quads. You know why I'm doing that, emissions. I'm going to reduce petroleum from 37 to 15. Again, I'm motivated to reduce our emissions. Okay, I've just taken a lot of energy out of our overall energy system. I need to get it from somewhere. Where am I going to get it? Before I do that, I'm going to take 11 quads from the electric system and put it into the transportation system. So I'm going to electrify the rail and the automotive part of our transportation. Airlines, it doesn't work very well. Right? At least not yet. And then increase the non-CO2 12 quads to 30. So non-CO2 is mainly renewables. Some people might not like it if I throw nuclear into renewables, so I say non-CO2. We're going to increase that from 12 quads today to 30 quads. And then IGCC's right here, integrated gasification is the sort of prime example of clean coal technology. We need to use coal, but cleanly if we can. So there's a technology there, but I'm not going to heavily rely on that one. 3 quads. So we'll take some of the reduction in coal and actually use it for integrated clean gasification, clean coal technologies. So that's a solution. So essentially, reduce your dependence on fossil fire, increase renewables, electrify the transportation sector. Makes a lot of sense, right? So what is it? So what does it do to the emissions problem?